And today our group will introduce the physics in your name. I will talk about Tiamat comet's orbit and its velocity. The first part I'm going to talk about is the comet's orbit. As we can see in the picture, the comet didn't orbit around the sun. This is not true because the sun's gravity will pull the comet and let it orbit around the sun. So in reality, the comet's orbit should be like the one on the right side.
Right.
The second part I'm going to talk about is the comet's velocity. In this picture, we can see that every 10 days, the comet travels the same distance. It is not true because it didn't follow Kepler's second law of planetary motion. The law states that a line segment joining the sun and the planet will sweep out the same area during the same interval of time. From the original novel of the movie, we know that the semi-major axis of the ellipse is 16 billion and 800 million kilometers, which is about 112.3 AU. Then I assume that the ellipse eccentricity is 0.9. Then we can get the equation of the ellipse. And that is the picture of the ellipse with the sun on one of its focus. The three distances here are about the same, just like the one here. And then after calculation, we can see that the three areas are not the same, which didn't follow Kepler's law. The area closer to the sun is much smaller. So in reality, the velocity when the comet is closer to the sun should be higher in order to sweep out more area. And when the velocity is higher, the distance it travels will be also longer. This is the video that I create about what will happen in reality.
Okay.
The green arrow means the velocity. So we can see that when they are closer to the sun, their velocity will be higher.
So which one is the comet?
These two.
Okay. So why there are two? What's the difference?
Oh. I forgot to delete this one.
Oh, okay. So we should
yeah.
put the sign
Yeah.
up. Okay. Excellent. Please make sure to put the link into your report.
Okay.
So people can watch it. Okay. It's very good, Master. Yeah, very nice. Okay. Next person.
Hello, my name is Vincent.
Vincent.
Yes, and we talk about the meteor rate falling.
Okay.
Okay. And in the movie, the meteor falls like this. What? 跳一下。
This is a girl falling, not the meteorite.
Sorry. Wait, it's like this. Yes, the falling is like this.
Okay.
And you boom. Yes. Okay. So next page. The movie is that bad. But actually, when meteor rays enter the atmosphere, it has the friction can cause the surface to heat up because it have a it has a fish. Yes. So it will be it's V is slower and before the explosion before the memory falls, it will it's explosion. Yes. First, yes, it's like this. So the bin of the materials will be smaller. Yes. And we talk about the conversation of momentum. The conversation of momentum is that the momentum before the explosion and after the explosion will be equal, like this one, like the P is P1 plus P2 plus P. If we broke for n pieces, the P will be equal to the initial and final, the initial P and the final P will yes.
Yeah, people understand. Next slide, please. So what's your conclusion?
Sorry, next page.
Yes.
Okay, the explosion, before the explosion, the P will be, the explosion, the P will be 0, and after the explosion, sorry.
Finish.
Okay.
Summarize that.
And after the explosion, the P is 0. Yes, like this. Okay, next page. Okay. Meteorite will explode into fragments. Actually, the meteorite will explode into fragments, and the P and the momentum at the explosion is 0. But in the movie, the meteorite didn't explode. It falls. So it didn't confirm the conversation of momentum in the movie.
I don't agree. Okay, what's the problem at the first part? The
What?
first part that I mean you said like the meteorite burn, right? So
Yes.
what's the problem here? You talk about 2, right?
Yes.
What's the problem in the first part? Could you go back?
The so
What's the problem in the first
problem is the first is
here?
it have the fission, so it's V is small, is smaller, and before it falls, it will collapse into fragment.
It depends on the mass, right? If the mass is big, it can be a one piece to hit the ground, right?
Yes.
So I don't see the problem.
Hmm?
Second part, what is the problem? Why the momentum needs to be conserved? -1, okay?
Second one, because
Second part, what's the problem?
because the momentum didn't equal to the initial.
Oh, where and where? Please show.
And
Where?
sorry. Here.
I don't understand. I don't see the problem here.
Hmm?
I don't see the problem. Please explain.
The
Meteorite came down, right? Hit the ground.
yes,
So where's the problem?
because it should explode first. It should explode first, but it didn't. But it didn't explode, and if falls.
That's nothing to do with the conservation of the momentum, right?
Hmm?
It might break down, it might not, right? Okay, Benson, I'm sorry, I don't understand your program. So please explain better in the report.
Okay.
Okay,
Thank you.
let's go to next person. I don't see physics problem here. Next.
I'm Ricky, and I want to talk about rectilinear propagation of light.
Okay.
And this picture is a scene in this movie, and we can see the shadow and the bright part. and the boundary is not a straight line, it's a curve. And we can, yes, and we can see the window is a square, so I think this is impossible.
Yes.
Mm.
Oh,
Okay.
we noticed.
And the normal shadow is like this. It's a straight line.
Is that straight? That doesn't look straight too.
Straight.
Okay.
Okay. Okay. And light propagates in a straight line in simple. And however, under the influence of the gravitational field of other objects like black holes, the line will the light will become a curve. Next. And
You -1, okay?
We can see this picture, and this is the Earth, and the galaxy is behind a black hole or galaxy cluster, and the light will influenced by this galaxy cluster, and we can see this galaxy behind this galaxy cluster. And this is the video when the galaxy walks through behind the black hole. Okay, this is my introduction.
Okay. Interesting. Okay, so can you go back to the first image? And please, so the light is bended, right?
Yes.
So that means there's a black hole.
Maybe.
Please calculate what the mass of the black hole. What kind of black hole is there in your report?
Mass.
Yeah, mass
Okay.
of the black hole. What kind of black hole is there?
Okay.
Okay, good.
Thanks.
Interesting. Yes. Okay. Good job, Ricky. Next person.
Okay. Okay, my part is about the speed of the electricity.
So what's your name?
My name is NTHU.
Are you Jackie?
Huh? No.
Usually.
Oh, Danny.
Danny. Okay.
Yeah, I'm Danny. Okay. Okay. This is the scenes in the movie, and you can see that the time takes several seconds, and to get off in the just you can see the light around the lake is gradually go out, gradually, not in a moment. Okay, but I think in the reality it's about this, just a moment that the light or the road is go out in less than 1 second. Okay.
That's true. Yeah.
Okay. And then I will calculate the speed of the electricity, and okay, the speed of the power is not depend on the electron speed, but is depend on the speed of the electromagnetic, because the speed of the electron is very slow, very slow, and how to calculate the speed of the electromagnetic? You can think about the formula. You see now, and the epsilon is the electric constant, and the mu is the magnetic permeability. And in common electrical wire, in common wire, it is made up of the PE. PE is the
polyethylene, and the Cu, and the epsilon of the P is about 2.3, and the mu of the Cu is about 1, and we can calculate that the speed of the electromagnetic is about just like, and it is very nearly the light speed. And next, and we can assume that the distance between the town and the electrical station is about 50 km, and the time of the transport, the power from the station to the town is about just very small. Okay.
Okay, very good.
Yes.
Very good. Okay, so can you show that light out movie again? The movie again. So the.
Is it?
So
Oh.
this,
回去。就是这是 this is the station. Okay. 这个 this is in the mountain. This is station.
power station.
Yeah. 然后 it's okay. Yeah.
Okay, so then you know that the speed of the light that you use is in a vacuum, right?
Yeah.
In media, speed of the light can be slower, right?
Yeah.
So can you estimate the speed of the light just measuring from the movie, and then see what kind of media is this the light? Okay, so if the area is filled with a very dense gas, it may be possible the speed of the light is that slow. So can you calculate what kind of density is required, and then what kind of gas is needed?
What?
Do you understand? The media.
Hey,
Okay,
media.
speed of the light you measure from the movie, okay? And then what kind of media
Hey.
can make the speed of the light as slow as you calculated?
Oh.
Okay? That's
Okay.
in your report.
Okay.
Okay? Thank you. But very interesting. Okay. So next person?
Hello, my name is Yu-Si Zhang,
Okay, you see.
and today my topic is the falling speed of small and big meteorites. In this scene, we can see that the small meteorites fall first and then the big meteorites.
Okay.
Okay, so to get the terminal velocity of the meteorites, we use the terminal velocity formula, and we can consider the cross-sectional area of the meteorites and the air density, and we can see the air resistance to do effect on the speed of the meteorites. And first, we consider the major meteorite fragments, and according to the netizens, they collect the data of the major meteorite fragments. The diameter of these fragments is about 40 meters, and we can calculate its volume based on the diameter, and then the mass based on the density of the meteorites and its volume, and finally we can calculate the cross-sectional area of the meteorites. And then is the small meteorite fragments, and generally the diameter of the small meteorites is about 1 meter, and then we can calculate the volume of it and the mass and the cross-sectional area. And we use the formula earlier, and we can see that the velocity of the major fragments is about this speed, and the small fragments is about this speed, and we see that the major speed is bigger than the small. And so we can see that it is false that in the thing that the major fragment has a much higher terminal velocity due to air resistance, because the small fragments of the meteorite indeed has a bigger air resistance due to the density of it. And so we can see that it is false in this thing. Thank you.
Nice, very nice. Can you show the movie again?
Okay.
Small one was coming first.
And it's much slower.
Ah, the very big one is coming in, yeah.
Yes.
Oh, very interesting. But they, as Benson was saying, they sometimes, break down into small pieces, right?
Yes.
The initial velocity is the same. So when they explode, small one was maybe straight down, but the big one was maybe going the other way or something.
Yes.
Is that possible?
Yes. Huh?
Is it possible that they started at the same time? Maybe small one.
But it is very close to the ground, so it's the bigger is here and the small is very fast, but the bigger is almost here, but it's still slow.
Yes, you're right. But I'm just thinking possibility. So Benson said it's gonna break down, right?
Yes.
And the small one break down straight down.
Yes.
And the big one went up a little bit and then came down. So small one came first and the big one late. Is that
Big
possible?
one, I think it's here, and you will.
Yeah, so later, right?
If first, it initially go up and that is here.
Yeah, that's what I'm talking about. Yes, yes. Is that possible?
But the next moment, she's died. It's very close to the ground, I think. But it is possible that the bigger is still flying.
Okay, okay. Anyway, excellent. Very good. Thank you, Yusi.
Thank you.
Oh, this is excellent. I didn't notice that. Oh.
It was my problem.
No, you have no problem. It was excellent.
And I am Jackie.
Jackie.
I'm talking about calculating distance. I use the time difference. And might be no voice, so I was telling the time difference. This is we see light, and just few seconds we hear the voice. There's no voice in the video. So we use the time difference to calculate the distance from the observation point.
Oh, interesting. So in a real movie, there's a sound later.
So
Okay. Good.
as a picture, we use this picture as describe the distance between this. We used to measure the diameter of this lake and compare with the reality. And we consider the transmission time of the sound wave and the transmission time of the light. And we subtract this number, we can get the time difference. And the detail setting, D is the distance from the observation point, and we use to calculate the diameter of the lake. And the speed of sound and light list here. And the time difference in the movie is the 5 seconds, and we cannot hear it. And we easily calculate the number. The distance would be 15 meters. And I tried to find the detail setting in the movie, just a precise number, but I can't find. So I compared two lakes in the reality, which is the basis for the movie setting. So this is the first, which is Siwa Lake. And I found the surface area from the Japan government research. So this is same as the perfect circle. So we try to use the surface area to calculate the diameter. And the result would be 4.04 kilometer. And we use the same formula to calculate this time difference will be 11 seconds. And the other lake is Matsubara Lake, and it's a small one, which is 0.12 square kilometer, and also the number of the diameter and the time difference. So the calculation that does not match the actual situation. Diameter should be 4.04 kilometer or 0.39 kilometer rather than 1.715 kilometer. And the time difference should be either 11.8 or 1 second rather than 5 seconds in the movie.
Okay, good. Well, it's very good, but then we don't know if it's these two lakes or not. Right? It may be a different lake.
Yes. I can find the precise data from the movie, so I chose to use the red.
Okay. Good. But very good point. Okay, so you measure the size of the lake. Good. Okay, good, Jackie. So we have Thomas, right? Okay, Thomas, you're next.
Hi, teacher.
Yes,
Hi.
morning. People can.
Yeah,
Yes,
I tell people can disappear. The next page, let's see the movie. Wow, the whole people is disappeared.
Right.
Okay, next. Then I tell why human can disappear. According to the laws of a conservation of mass and energy, the energy or mass can't be created or disappear in the air. Only can transfer to another things like energy, electricity, or else. So the mass or the energy of a human can't disappear suddenly without nothing create. And next. So what if a human body disappear in the air? According to the formula is energy and just energy equivalent, like E equal to mc square. Assume the human body is 70 kilogram and light speed is this. So if the human disappear will transfer a human body to increase the enormous power. Like if this power transfer to the electricity, it will generate the electricity for the thousands of years for the entire planet. Okay, the next year. Suppose people in the movie doesn't disappear suddenly. It may be just like in the movie, one character is connect to the past, connect to the people in the past. So and the times are he come back to his normal time and where he was. So according to the second law of the thermodynamics, the entropy in the university is a positive and increase. The delta is always positive and always increase. So the time is so the time can't come back. And says the time travel also usually talk about the relativity. According to the relativity, the time isn't absolute. So in this very the object is move very fast according to the light speed, so that his time will be very low. But the time can be reversed. So in any time and everywhere, time can be reversed. So people can interact with people from the past, the next. So so the people can whole body disappear in front of you. Okay, next. Thanks for everyone and thanks for attending.
Okay, very nice, Thomas. So it was good, but maybe in your report, can you look into quantum transportation and see if that can be applied to human? Okay, did you get the homework? Quantum transportation in your homework, okay?
Okay.
Okay, so do you guys have a quiz?
Yes.
Okay, let's do it.
Okay, see.
By the way, there's an English report too. You guys know that, right? There's another English report.
Yes.
Okay, good. Okay, please, everyone join.
这个应该不是吧？应该不是说这个。
You guys don't join, you know that, right? Okay. Okay, everyone join. Okay, let's get started.
Oh, sorry. It's my fault.
The answer is conversation of momentum. Because because it have the phase, so the energy didn't conversation and angular momentum is not because because I don't know what rotation and conversation of mass is called a chemistry. It's called about. Yeah.
We do again or not?
Yeah, let's do it again. Otherwise, the score will be weird, right?
again.
Wait, but next time everybody's gonna. Oh, we have to do pin again?
Yes.
Oh, okay, no problem. I think everyone's going to answer correctly on the first question.
Okay.
Everybody going? Okay. Let's get started.
It's okay. No one get the points. It's okay.
Yeah, okay. Who answered yellow?
Okay.
Okay.
就这样。
Yes. Okay.
I forgot.
The answer is the red.
What?
Sorry. Because I edit the answer and I forgot.
Okay.
Sorry.
No problem. Good, sharp. Okay, congratulations. Good, congratulations.
Sorry.
Okay,
It's my
no
fault.
problem. Okay, thank you very much. Group, I forgot the group.
7.
7. Okay. So shall we move on to group 8? Okay. Read, switch, quick read. Okay, good.